All right, good morning. Welcome back to PreCalculus. So we are going to be talking a little bit more about dot products. This is pretty much a nicer, or at least a more relaxed version of the last couple of problems where they gave us some vectors. And now they're just asking us, and they're saying, is this result going to be a vector or a scalar? Okay, so we have given a u, we have given a v, and they want to know what is twice the value of u dot v. Well, when I go ahead and take u dot v, we're going to get a scalar number, and then we take our scalar number and double it, we're still going to end up with a scalar. So that's all we have to do. It's just going to ask us, do you get a scalar or a vector? Okay, that's all there is to this one. Okay. Oh, that's nice. And then what is the actual, excuse me, what is the actual value for this thing? Go ahead and write that out. So we've got twice what u dot v is. Okay, so u is u is equal to -7, 3. V is equal to 7, -1. That's a comma. Okay, so what is u dot v? That's going to be -7 times 7. So -7 times 7, that's 49, -49. And then v, okay, that's going to be 3. So this is plus 3 times -1. Okay, 3 times -1. So we have -49 minus 3. That should be -52. All right. And then we're going to say what's twice that. Okay, so 2 times u dot v. That's going to be 2 times -52. That'll be -104. Okay, and that's really all there is to do in those. I know they're a little underwhelming as far as problems go, but you're learning a new thing. You're learning a new way to say it. So, I can't tell you how many little notebooks that we've signed up and done problems like this just to get practice at it. When you have to do this again in Calc 2 or Calc 3 or in Physics 1, and they ask you these problems, you're like, oh, thank God that we have some ones that I know how to do. And then we can just go through and do that. Okay, so this one says we have u, v, w, and all they do is write down v dot u with a w next to it. Like, well, how does that work? Well, u dot or v dot u is going to be a scalar value. We can take a scalar times a vector. That's fine. All right. So the result here is going to be a scalar, or is going to be a vector, because we've got a scalar times a vector. So that's still a vector. Okay. It has both magnitude and direction. Okay, and then they actually want us to calculate this thing out. So we're going to say v dot u. Okay, v dot u. Okay, and we'll do that, and then we'll apply this scalar product as scalar value to w, and then get an answer. Right. So it's u is -2, 5. So we have -2, 5 dotted with, and then v is 7, -1. Right. 7, -1. So v dot u, okay, these are commutative. You can swap the order with dot products. That's okay. So we have 7 by -3, or -2 rather, plus, and I have -1 by 5. And that's going to be 7 times -2 is -14. -1 times -5 is -5. So 14, 5 from 14, that's going to be 19. That's -19. And then we apply this -19 to what w was. What is w? W looked like it was 0, 1. So this is -19 times 0, 1. So we end up with 0, -19, and that is our value there. Okay, so result is a vector. It is 0 and -19. Okay. That's really all there is to that one. Hooray, we got our green flag. Okay, we'll go on. I think I have time to do one more for us for this one. So this is 3, 4. We might be able to do 5 here. Let's have a look. Oh, no, we don't. Okay, so we will come back. Sorry for making this longer than I needed to. I'll see you in the next video. Thank you.